we're going to start with number 1. Force of 25 newtons is required to start this box moving across the horizontal concrete floor. What is the coefficient of static friction between the box and the floor? Okay, the box accelerates this. What's the coefficient of kinetic friction? All right. So, number 1. So, doing my force diagram. F sub G down, force normal up. I'm going to think it's trying to move to the right. So I'm going to put my F going to the right, and my frictional force going to the left. Right? Correct? And then for part B, everything's the same, except I also have an acceleration to the right. So in case A, my acceleration equals 0, but in case B, I have an acceleration to the right. Right? Okay. So then doing my free body. We have gravitational, normal, F, frictional force. We have the first case when A equals 0, and the second case when A goes in that direction. Right? Just so I don't bug the people that don't need this one, who am I talking to that needs this one? Okay. Just good. That's fine. You need the whole thing? Alrighty. We'll do the whole thing then. So from here, free body in the X, F sub F, F sub G, F sub N, right? And so some of the forces in the X, MAX, and in this first case it's not accelerating. We get frictional force plus F equals M times 0. So you get that F must equal the frictional force. Right? Yeah. Sure. And then on this side, you get force normal minus F sub G equals M times 0. So you get the normal force equals the weight, which of course can also be written as mg for my equation sheet. Now maybe it's time to look and see what they actually wanted to know. What is the coefficient of static friction between the box and the floor? So remember, as we saw the other day, this frictional force will just keep building until it starts to move. So they want to know what force just starts it to move. So they tell us the force. They want to know the coefficient of friction, which I'm going to need to do over here because I'm going to have to do F equals mu force normal. And then I can substitute in for force normal, I can substitute it in mg from the other side. And a little rearranging gives me mu equals F over mg, right? They tell me F, I think, 24 newtons. They tell me M, 3.4 kilograms. I know G because I'm on the planet Earth. "24 newtons." Yeah. You okay over there? How many kilograms is that? 3.4. 3.4 kilograms times 9.80 newtons per kilogram. Me? Or someone else? Okay. I'm good? Okay. And pull out my calculator. So I need to do 24 divided by all of that. 24 divided by parentheses 3.4 times 9.8. Hello, Mr. Cochran. Hey, she's here. Sure. Okay. All right, so I get 0.720. So I get mu equals 0.720, and it's newtons over newtons, so it's unitless, which is good because it's a coefficient. And then if the 24 Newton force continues, the box accelerates at this. Was the coefficient of kinetic friction. So what I'm going to do is I'm going through very similar setup here. Remember, because the only thing that's added to my free body up here is that acceleration here in part B. I have is this acceleration in this direction. It's not going to change my free body in the y at all, right? So my normal force still equals the weight. But what's different is from this step down. So I'm going to, let's see, let's do it over here. This will be part B. Okay? I'm going to have negative frictional force plus F equals M times A. So I'd end up with that my frictional force equals F minus MA, right? Yes? No? Okay. So mu force normal equals F minus MA. So mu times mg equals F minus MA. So mu equals F minus MA over mg. So mu equals 24 newtons minus 3.4 kilograms times 0.5 meters per second squared. I think that's right. Didn't it say half? Yep. All over. It does. Right? Oh, do you want me to leave it turned on? That's why we've got that. And Okay, let me do a little math. Parentheses, 24 minus 3.4 times parentheses divided by parentheses. All good. And I get 0.669, which makes sense because it should be less than my previous one, since it's now accelerating when the same force is applied. So let me check those. Number 7, the 22 kilogram box, at least on this angle of incline, accelerates down the incline at this. Find the frictional force impeding its motion. Oh, this is a good one. I like these for like the in-class problem sets. These are good, overall, do they understand it ones. So, like number 7. Let's see what information they give us. 39 degrees. See that we'd have a gravitational force down, a frictional force up, a normal force like that. Tells us we're accelerating. Yeah, that should be your force diagram. Now, do you guys want to keep doing this in X and Y, or rotate it to parallel and perpendicular? That would be my recommendation. That's a smart choice there. Smart choice. So, how that would change it, we'll say that parallel is in that direction and perpendicular is up in that direction. That would mean our frictional force was in parallel, our normal force perpendicular, our acceleration parallel, and it's only our gravitational force that's at an angle now. Good choice, good choice. And so that's the only one I need to do components of. I need to do a vertical component and a horizontal component. And because of the rotation, this is 39 degrees. That's how much I would have rotated this counterclockwise. So this side is FG cosine 39 degrees. And this side is FG sine of 39 degrees. Right? Move on. Can we move on to the individuals? So rather than X, this is going to be parallel. Rather than Y, this will be perpendicular. And perpendicular, we have two forces, normal force and FG cosine 39 degrees. Horizontally, we also have two forces and an acceleration. We've got FG sine 39 degrees and frictional force. So those are our two free bodies. And I'm interested in frictional force, right? Because I'm interested in the mu for it. So my gut, just because I know how these problems go, I'm going to start on the other side. All right? Because I know I'm going to end up needing the normal force. They didn't tell us. So I'm going to start over here. And I end up with force normal minus FG cosine 39 degrees equals m times 0. So the normal force equals the component of the gravitational force that's perpendicular to the surface. If you want to be very technical about it. Parallel equals m a parallel. And I've got negative frictional force plus FG sine 39 degrees equals m times positive A. So I'm going to rearrange this and have frictional force equals F sub G sine 39 degrees minus MA. Right, just rearranging that because I know I'm going to need that frictional force by itself. Thank you very much. Evan and Megan, presents for you guys. Thanks. So mu force normal equals FG sine 39 degrees minus MA. So mu going to equal FG sine 39 degrees minus MA over force normal. Lots of fun algebra, right? Now we just substitute in mg sine 39 degrees minus MA all over, I'm going to, this one I could have written, right? mg cosine 39. So this could go over mg cosine 39 degrees. Anything cancel out of that big old mess? Nope, because the MA doesn't have an mg in it. M. Doesn't every term have an M? Yeah. So M cancels out. So does the mass of the box matter? Like if I had a 10 kilogram box and a 3 kilogram box, is one going to accelerate more than the other? No, it's always constant. And that's how like package delivery systems like at UPS and everything, that's why they don't care about the mass of the package. They all go through the conveyor belts at the same rate because of that cross out right there. And now it's really substituting in 9.8 newtons per kilogram sine 39 degrees minus, what acceleration does it tell me? 0.272 minus 0.272 meters per second squared all over 9.80 newtons per kilogram cosine 39 degrees. And I put in all those into my calculator. What fun. Let's see. Parentheses, 9.8 sine 39, close parentheses, minus 0.272, below the top, divided by, start at the bottom, 9.8 cosine 39. Yeah. 0.774. Alright, so of course, what I just realized by flipping back here to the problem was that it first asked, what is the friction force impeding its motion? Funny, when I did this in one of the other blocks, I think it was A block, I forgot to go this far. But now you can just go back up and where's this one? You can go back up and plug in your values here now for the frictional force. Now you know everything. So my last step on this would be to plug in for the frictional force. And I'd plug in mg times sine of 39 minus m times a. Because they do tell me m. Okay? Yeah. So now you go back. Since you have the coefficient of friction now, you can go back into here. You're looking for frictional force. You know this is mg sine 39 degrees minus ma. And guys, a little too loud, please. M is, they tell me, is 22 kilograms for mine. G is 9.80 newtons per kilogram. Sine 39 degrees minus 22 kilograms. And my A, if I remember right, was 0.272. Meters per second squared. And then I just plug all that in and I get the frictional force.